Hi everyone, this video is on the mixed exercise 9 question 32. In part A, we want to find divide by dx of the given function. So this is an implicit differentiation, but we should note that it also needs us to use the product rule because on the left hand side we have the product of two different functions. And I'm going to write down the first function times the derivative of the second function. So the second function is 2 plus y, and that differentiates to y differentiates to 1, but as it's a dependent variable, we also write divide by dx. So it's going to be divide by dx because 1 times divide by dx is just divide by dx, so that's why we just have 1 plus x divided by dx. Then we write the derivative of the first function times the second function. So 1 plus x differentiates to 1, and 1 times 2 plus y is just 2 plus y. On the right hand side, x squared differentiates to 2x, and y squared differentiates to 2y, but again, since it's dependent variable, it's going to have dy by dx. Okay, at this point, we can rearrange the equation and then take a factor of dy by dx so that we can have dy by dx in terms of x and y. That's usually the second step in implicit differentiation. Even in question, they mention that. And so I'm going to keep 1 plus x divided by dx here. And then I'm going to take away 2y divided by dx. So I have that on the left hand side, 2y divided by dx. And I'm going to move everything else to the right hand side. So we have 2x. We are going to get minus. So just let's rewrite 2x. And then minus 2 plus y. This bracket will be gone to the right hand side. Okay, at this point, we can now factorize divide by dx. So it's going to be 1 plus x minus 2y is equal to, then here is just 2x minus 2 minus y. And we can divide both sides by the bracket on the left hand side. So we have divide by dx is equal to 2x minus 2 minus y over, I don't need the bracket anymore. So I just write 1 plus x minus 2y. Okay, so this is the derivative and the answer to part A. So for part B, we want to find a gradient of the curve at each of the 2 points where the curve meets the y-axis. Okay, so we first need to know what are the points so that we can find their gradients. And the 2 points that we are interested in are the 2 points where the curve meets the y-axis. And let me remind you that when a curve meets the y-axis, its x coordinates are 0. So this means that we need to substitute x is equal to 0 into the equation of the curve, and that allows us to find those y coordinates of the points that we are interested in, and then we can find the gradients of them. So all we need to do for the first step is substituting x is equal to 0 into the equation of the curve, and as a result of that we are going to get 1 plus 0 times 2 plus y is equal to 0 squared is obviously 0 plus y squared, and we can rewrite this as 2 plus y is equal to y squared. Now we have a quadratic, so let's solve this quadratic to find the y coordinates. Y squared minus y minus 2 is equal to 0. So we can factorize this, y minus 2 and then y plus 1. So the solutions are going to be y is either 2 or y is equal to minus 1. Now, remember that the x coordinate of both of these points is 0, right? Because that's a y-intercept. And therefore, the 2 points that we have are going to be 0, 2 and 0, minus 1. So all we need to do now is just substituting each of these points separately into the gradient function, or just the equation of the first derivative. I mean the equation of the first derivative. in order to find the gradients at each of these points. So at 0, 2 divided by the x is equal to, so it's going to be 0 minus 2 minus 2, so 0 minus 2 minus 2 over 1 plus 0 minus 2 times 2, which is minus 4. So 1 plus 0 minus 4. And we can simplify this, and we are going to get minus 4 over minus 3, which is just 4 over 3. So this is the gradient at the point 0, 2. Okay, for the other point, which is the point 0 minus 1, divide by the x is equal to, let's see. So again, it's going to be 0 minus 2, this time plus 1. So 0 minus 2 plus 1. And then we have 1 plus 0 minus 2 times minus 1, which is just 2. So 1 plus 2 basically here. And we are going to get minus 1 over 3. So that's the gradient of the second point. Okay, now let's answer part C, which is the more interesting part of the question. So in part C, let's understand what's happening. We want to show that there are 2 points at which the tangents to this curve are parallel to the y-axis. Okay, so what's going on here is that we have a tangent line that's parallel to the y-axis, and we want to show that there are 2 points that this is the case. Now, in order to show that, that basically means that we basically find the coordinates of the 2 points. That's one way to show that that's the case. But before that, we need to understand what does it mean when the tangent line is parallel to the y-axis. So we need to know the gradient of the tangent line, right? Because two lines that are parallel, they have equal gradients. But whenever a line is parallel to the y-axis, remember that y-axis is just a straight vertical line. And its gradient is actually undefined, right? Because if you just try to find the gradient of that line, you are going to have 0 in your denominator. So the gradient of the y-axis is basically undefined. So since this tangent line is parallel to that, therefore the gradient of the tangent line is also undefined. Now don't let that confuse you, because what this means for us is actually a clue. Because the first derivative, as we found, is equal to 2x minus 2 minus y over 1 plus x minus 2y. So since we know that the tangent line has an undefined gradient, that means we need to make an equation here, form an equation such that it's basically that satisfies that condition. So now, if we want to get an undefined gradient, we just simply need to have the denominator to be equal to 0. And if we want that to happen, then we can basically form an equation. So with that said, all we need to do, we need to solve the equation when the denominator is equal to 0, because that's when the gradient is going to be undefined, and that's the case that we are interested in. So by doing so, we can just solve a few equations and then just get the 2 points that we need to answer the question. Yeah. So all we need to do right now is just solve this equation, because remember the denominator of divided by x is 1 plus x minus 2y, so we just want this to be 0. 1 plus x minus 2y is equal to 0. Okay, at this point, one thing that we can do is we can write this in terms of y, so just rearrange that to have x is equal to 2y minus 1. And then at this point, since we want to find the coordinates, what we need to do is basically substituting x is equal to 2y minus 1 into the equation of the curve. So substitute x into the equation of the curve. And let's substitute that and then solve that to find the coordinates of the points. So the equation of the curve is bracket 1 plus x So instead of x, I'm going to write 1 plus 2y minus 1 times 2 plus y, then is equal to x squared. So I'm going to write 2y minus 1 squared plus y squared. Okay, let's simplify and rearrange this. From the first bracket, the ones will cancel each other out, and then we are going to have 2y times the second bracket, which is going to be 4y plus 2y squared. And this is equal to, now let's expand this bracket. It's going to be 4y squared plus 1, and then minus 4y, then plus y squared as well. So let's now simplify and rearrange this. 4y plus 2y squared is equal to, on the right hand side, we are going to have 5y squared minus 4y plus 1. Now let's move everything to the left hand side as usual. Or, yeah, that's fine. I mean, or we can, yeah, move everything to the right hand side to have that, as positive. So it's going to be 3y squared minus 8y plus 1 is equal to 0. Okay, now we just need to solve this equation, and I'm not going to write down all the steps, but if you solve this equation, should get y is equal to 4 plus or minus root 13 over 3. These are the two solutions of y. And now we can find the values of x, because previously we said x is equal to 2y minus 1. So now we can find the two values of x. First, when y is equal to 4 plus root 13 over 3, then the corresponding x value is going to be 5 plus 2 root 13 over 3. And when y is equal to 4 minus root 13 over 3, then its corresponding x value is 5 minus 2 root 3 over 3. Sorry, root 13 over 3. And yeah, so these are the coordinates basically. When x is has this coordinate, then y has this coordinate. And same thing applies to the second one. All right, that's it for this video, and thank you for watching.